All right, so this is the first part of limits. It's not even going to actually be all of the day one lesson because we're splitting this over extra days this week because I want to review a little every day and I want to introduce limits a little every day, okay? So the first thing we're going to talk about, whoops, I don't know what I got going on here. Back in Chapter 1, we determined whether a graph was continuous or not. We didn't spend a lot of time on this. What are some of the things that made something discontinuous? Does anybody remember? Okay, there was a jump. We did those primarily with things like piecewise functions, remember? Where there was a different rule. Okay, something that made the denominator 0, so there was an asymptote or something, right? Then there was some discontinuous place. All right, we're going to talk today about limits. This is the first lesson you'll learn in calculus next year. So Ms. Gupta said, well, you really don't have to do this. Well, I do because it's on our final, but I also do because every year students come back to me and say, the first week was so easy because we did it last year. Okay, limits is not a super hard concept. We're going to talk today about limits at a point. Tomorrow we're going to talk about limits at infinity. All right, so it says calculus centers around two fundamental problems: finding the equation of a line tangent to a graph of a function at a particular point, and finding the area between the graph of a function and the x-axis. Fundamental to the solution of these problems is the understanding of what's called a limit. Okay? You can apply this to estimate the limit of a function as x approaches a fixed value by graphing or making a table of values. So we're going to talk about this notation as the limit of the function as x approaches c. C is going to be an x value, and the limit is going to be the y value that the graph is approaching. So if we have this is not rocket science, guys. This is a graph of a line, yes? Crosses at 1, has a slope of -3. It is continuous, right? So we want to know what is the limit doing as x approaches 2. So as we get closer and closer to an x value of 2, the y, here's closer and closer, the y is getting closer and closer to a y value of what? What are these y values approaching from both sides? -5, right? Okay, we'll eventually learn that, yes, this is a problem where you could have done direct substitution by putting in the 2. You get -6 plus 1 is -5, and it's, but the limit is not what the value is at 2, it's what is approaching at 2, because sometimes at 2 it's undefined. So this is an example of that. This graph, I can't do direct substitution. A 3 would make the denominator 0, okay? It is undefined at 3. But if we graph it, we can see the graph. What's the y value doing as x gets close to 3? Looks like it's getting close to 6. Then we try values in our table close to 3. 2.9, 2.99, 2.999. And then on the other side, okay, 3.1, 3.01, 3.001. In both directions, this is approaching what in here? 6, okay? Even though this graph is undefined, there is no y value of 6. You can't get a y value of 6 because you'd have to put in an x value that is undefined. You can still say it's getting very close to 6. It has a limit of 6. All right. To do that, where you put it in your calculator and find values, you want to have the table set to Ask Auto so that you can type in values. We've done this several times this year, okay? That is under second window. Okay. Second window to set it to ask auto. Okay. We're going to be in function mode. Good question. Function mode, and degrees or radians won't matter because we're not doing trig functions today. Okay. So please look up here. This is an important definition. It says the limit of a function as x approaches c does not depend on the value of the function at c. Okay, so the limit here, it could be approaching, the limit here is L as it approaches C, even though the graph is undefined there. Here the limit is still L, even though the graph is defined up here for C. The limit is what it is approaching, not where it's at. And the limit here is L, even though the graph is defined as L at C. Okay, that'll make more sense as we do some examples. One more time. It's important to understand the limit is not about what happens at the number, but as it approaches that number. Okay? A limit is about what happens near or close to that number. The other thing to remember is that the limit is a y value. We'll do a bunch of these and all of a sudden people are giving me x values. That's not the limit. Okay? We're going to talk about one-sided limits. What is the value approaching as it comes from? I don't know if you remember this, but we did this on one worksheet. We did just a few of them on one where it says this meant as it gets close to 8 from the left or from the right. Do you remember seeing that on one worksheet one time? Maybe not. So it can have a left-hand limit or a right-hand limit, which makes this definition a little bit easier. It says the limit of a function as x approaches c exists if and only if both one-sided limits are equal. So it has to approach the same value from both sides. We're going to talk about when it doesn't, like this. This has a left-hand limit. As x gets close to 0, it's staying at -2. As it gets closer to 0 from the right, it's staying at +2. But that means because the left and right-hand limits are different, the limit at 0 does not exist. Okay, from the left it was at -2, from the right it was at +2. So it has a left-hand limit and a right-hand limit, but if they're not the same, the limit does not exist at 0. Okay, this is an example that even though there's a dot down here at -3, as we got closer to -3 from the left, the y value was, what is that, guys, 4? As we got closer from the right, the y value was also 4. And since they're the same, we can say the limit at -3 exists and is 4, even though it's really down here. Okay, it was getting close to 4 up here. So what is it getting close to? Not where is it necessarily at? This is a weird graph, but this is the one that's on your paper. It says this. Find all of these different things, okay? Estimate the left as you will get closer to 2 from the left. That's what this piece means right here, okay? As I get closer to an x value of 2 coming from the left, what y value am I at? +1. Is everybody okay? Which it says here, but the second one says, as I get close to 2 coming from the right, you see the little plus sign? Well, here's the x value of 2, but the graph is up here as I get closer from the right, yes? What y value am I at? 2. So the limit at 2, because from the left and the right it was approaching 2 different y values, we say this limit does not exist. At 2, it jumped. It was coming from the left once and the right once, so it does not exist at 2. All right. This is going to ask about the limit as x approaches 4. This is the graph. As I get really close to 4 from either side, the values are getting huge, okay? The idea here is going to be that the limit does not exist. However, because both sides agree and are approaching infinity, we can describe the behavior as approaching infinity. This needs to be really clear in your mind. Okay, whenever you write down an infinity, it is important to understand that the expression approaches negative infinity or approaches infinity are descriptions of why the limit fails to exist. Those symbols are just showing what the end behavior is doing. They are not real numbers, so the limit doesn't exist. You won't do this in calculus, but I'm going to have us practice writing does not exist and then infinity, okay? Just so you have it clear in your mind that when we write infinity, it really means the limit doesn't exist. This is one that asks what it's happened as we get close to 0 from the left. As I get closer and closer to 0 coming from the left, this is going down, okay? As I get closer and closer to 0 coming from the right, it's going up, okay? So while we can describe the left or right hand limit, that it doesn't have a limit because it's not even going the same direction on both sides. The other one didn't have a limit either, but we could at least describe that both sides were going up. This, you would just say the limit does not exist. Again, this should be the easiest thing ever, but do you understand how to get closer to 0 from the left? You'd have like negative 0.1, negative 0.01, negative 0.001. You understand what I'm talking about? That's getting really close to 0. From the right, you could say 1, 0.5, 0.1, 0.01, 0.001. You're getting closer and closer. And those are approaching different numbers. All right. You will eventually have things that do what are called oscillating behavior. When you see this behavior, okay, in general, it means a limit doesn't exist where that oscillating is going on, but it doesn't mean the graph can't have a limit somewhere else. So this is a cosine of 1 over x, so the limit at 0 doesn't exist because it jumps around. Here, this is sine of 1 over x. Again, I graphed it on my graphing calculator, zoomed in, and this is what I got, so the limit does not exist. This graph, okay, at 0, well, at 0, it's at 0. On either side of it, it's very close to 0, so this would have a limit of 0. All right, so a limit does not exist if it approaches a different value from the left than from the right, or if it increases or decreases without bound from the left or the right. In other words, it's swooping up or down, or if it oscillates between values. It just means goes back and forth. All right, we're going to try these, okay? Now, I already put graphs on here because I kind of want this to go fast, but let's do a few. First of all, do you even remember how to type an absolute value into your calculator? Okay, I need to be in function mode. I'm going to just put everything to the left here on mine. Okay, it is under math. Arrow to the right to the number menu, and then it's ABS. 3x goes in the absolute value, and then divided by x goes on the outside of the absolute value. Okay, you could just do a zoom 6 for a standard window. And the graph jumps, right? So it asks, what is the limit approaching? How do I read this? As we get close to 0 from the right. So as x was getting closer and closer to 0 from the right, what was the y value? 3. Okay, what are some numbers if I went to my table that I could put in to test that? Okay, get close to 0 from the right. What are some numbers close to 0 from the right? 1. Okay, 0.5. Am I getting closer to 0? 0.1. 0.01. Right? Staying at 3. It's not a very tricky graph. Okay? This one is absolute value of x minus 2, and then divided by, we need parentheses around the denominator, right? X squared minus 4. Okay, again, I'm just going to do a standard window and see what I see. I don't know if this will be a good window or not. It's a little iffy. I might try a zoom decimal just because it shows a little better. But I want to know what's going on where. -2 from the left. Here's -2 on my graph, and I'm coming from the left. So what's it doing? Looks like it's getting really, really big. How would I test that? If I went to the table, what's getting closer to -2 from the left? -3 is to the left, right? -2.5. What's just below -2? -2.1. -2.0001. Is that really close? Do those numbers indicate what? I got 1, 2, 10, 10,000. Yeah, it's approaching infinity. So the limit from the left does not exist, but the graph increases without bound. So we can describe it as approaching infinity. A one-sided limit, you can just use infinity. It's no big deal, okay? All right, what about this? We'd have to put in the top in parentheses, right? Parenthesis x squared plus 3x minus 10, close parenthesis, divided by parenthesis x minus 2. Okay, wants to know what's happening at 2. My graph just shows a line. But if I trace at 2, it's undefined. Do you have parentheses around the top and around the bottom? You have to. This is how you have to have it typed in. I'm on number 3. I don't know. Okay. It's asking about what's happening near 2. So here's what I did. I put in 1.999, I put in 2, I put in 2.001. Okay? How do I know if it has a limit there? It was undefined at 2. Do I put no limit? No, because just above it and just below it are approaching the same value, I can say the limit would be at 7. Okay, are you getting how to do this a little bit on the using the table thing? Okay, as close to 2, so 1.99999. What's the other side of 2? 2.001. Those are both really close to 7. I'm golden. Okay. Here's a graph. If you just want to look up here, you don't have to do this one on your paper. It says, what is the limit at 3? Okay. So at 3, it looked to be not a good plan, right? Because one side's going down and one side's going up. I tested just below 3 and it went to negative 6,000. I tested just above 3 and it went to positive 6,000. Does that mean the limit is 6,000? No, because negative 6,000 and positive 6,000 are very different. Okay, the limit does not exist. And you can't even describe it because it's going different ways on different sides. All right, here's this one. What do you think? At negative 2. Yes, it does not exist, but we could put that it approaches infinity. Oh my goodness, that's the lumpiest looking infinity ever. Okay. This one, okay, if I put a 4 in, it's undefined in the denominator. But here's what happened when I put 3.99 and 4.01. What do you think? Can you read that? It's approaching 8. Last question for today. As this is asking what? Negative 1 from the left. Here's negative 1. What are some numbers I could test? What's just to the left of negative 1? Negative 1.0001. Those are just to the left, right? What do you think I'm going to get? Really negative numbers, right? So you could say the left-hand limit approaches negative infinity. What is the right-hand limit approaching here? From the right, it's going up. So if it said, what is the limit as x approaches negative 1 of this function, you would tell me what? Does not exist. Okay? This is a description of it from the left and a description of it from the right. All right. If you want to practice a couple of these on your own tonight, at the bottom, okay, you could just try maybe these 5. Even skip 11 if you want. We can talk about this. You would be in radians if you're doing this one. We could do 11 tomorrow. Okay? I'm switching